Hello everyone and welcome to page 30. Today we're talking about page 30. We're going to go on and talk about how to find the surface area of a prism and a cylinder. So we've got these two shapes that we need to look into how to find our surface area of. So let's jump right into it then. So again, like we talked about yesterday or whenever you watched those notes from before, surface area is just the area that's around the outside of a solid, right? It's just the covering of some sort of figure. So I didn't really dive, oh, I did put it right there. There you go. Surface area of a solid is the sum of the area of each face on a solid. So the sum of the base, and then each face around the side. So for example, if you had a pentagonal prism, you would have a pentagon on the bottom and a pentagon on the top, so two pentagons, and then you'd have 5 rectangles around. So you're going to find the area of the pentagon on the top, pentagon on the bottom, the 5 rectangles on the side, and then add all 7 of those shapes together. With that said, that would be a lot of work to find each of those things, unfold it into a net, do all that. I have a formula for you to make this a little bit easier, and I did cylinders and prisms at the same time because they're kind of the same. So the formula you have to know for this is surface area equals 2b plus ph. Important to recognize that b is a capital B, not a lowercase b. When you see a lowercase b, they just mean the length of the base. But if you see a capital B, they mean the area of the base. Okay? So surface area is equal to 2 times the area of the base. That 2b right there, that is the 2 bases, right? In a pentagonal prism, you'd have a pentagon on top and a pentagon on the bottom. Those are your 2 pyramid, or your 2 bases. So you have 2 area of the bases. You find the area of one base and you multiply it by 2, and that covers both of those. Then perimeter times height. Well, the reason that happens is if you look over here, think about my pentagonal prism, right? I would have the pentagon on the top and the pentagon on the bottom. So this is the 1b and 2b. Well, then you have all these rectangles on the side. There's a rectangle that connected these two. Then the rectangle that connected this one to this one would be right here. And the rectangle that connected this one to this one would be here. And the rectangle that connected this one onto this one, we could put over here. And the rectangle that connected this one to this one would be here. So you can see all of those rectangles then end up there. So think about this. If this folded down and wrapped around, this base would go onto here. And this base would go onto here. And this side would go onto here, and this side would go onto here. Which means the perimeter of this pentagon is the same as the length of this really big rectangle. And then the height right here is the height of that rectangle. So if you do base times height, you get the area of this whole rectangle, or perimeter times height. Perimeter is the base. So perimeter times height will give you the area of that big rectangle. We're going to do the rectangle all at once. So learn that formula because it'll definitely help speed things up a little bit for you. I think we jump right into our first example at that point. We sure do. So, example 1. So my first example is I have a rectangular prism, and we will find the surface area of that rectangular prism. Okay? So we're going to think about our formula. Our surface area formula is surface area is equal to 2 times the area of the base plus the perimeter times the height. I told you before that rectangular prisms are a little weird because you got to focus on which one you want to be the base and which one you want to be the lateral surfaces. So I think what I'm going to do is I'm going to use this top piece right here. This is going to be the base of my prism, this big rectangle up top, which means that the rectangle on the bottom, this one right here, that I'm kind of like highlighting a little bit in, that one right there would be the rectangle base on the bottom. So we just need to find the area of that base first. So big B is equal to, well, how do you find the area of a rectangle? Hopefully from last week you practiced these formulas, you memorized them like I stressed last week. We know area of a rectangle is just base times height. So looking at just this rectangle, only focus on that rectangle. I can even break it out right here so we can see just that rectangle so that we don't get confused. We know that it's 12 feet this side and 6 feet this side. So if I want to find the area of this, we're going to do 12 times 6. 12 times 6, 12 times 4, 36, it's going to be 72. So that's my big B. Next, I need to find the perimeter of the base, right? That was big B. Now I need the perimeter of the base. Well, perimeter is equal to all of those things added up. So I know there's a 12 on this side and a 6 on this side. So I would add 12 plus 6 plus 12 plus 6, or I think I put 12 plus 12 plus 6 plus 6. I don't know what I did there. 12, 24, it looks like 30 and then 36. So perimeter is 36. The last thing I have to find is the height of the prism, and this is where I think most people will make mistakes. It is not the same as this H. This H and this H are different. This is height of the base. This is height of the prism. Go back and look at your prism. How tall is the prism? In other words, how far is it from the base on the bottom to the base on the top? Well, that's going to be this distance right here. Here's the base on the bottom, here's the base on top, and they are 4 feet apart. So I know that my little h is 4. I can now take all this and plug it in. Surface area is equal to 2 times the area of the base, which we said was 72, plus perimeter, 36, times a height of 4. And I'll multiply this. 2 times 72 gives me 144. 36 times 4 also gives me 144. That's a coincidence. And when we add this together, we get 288 for my surface area. Now again, since we're talking about area here, we're going to use units squared. Remember, area has units squared, so we'll put feet squared, and that would be the surface area of a rectangular prism. They are, I think, the easiest and the hardest at the same time, because it's kind of hard to see where the base is and where the base isn't. So jumping back over here, just so we have a nice clean version of it. There is my clean version of the notes. If you'd like to pause it, write it down, see it a little bit nicer. I'm going to jump over to example 2 right now, though. I know it's a little quick, but you can pause that video and get what you need from there. So example 2. This one had a little part get cut off over here. Even in the notes, it kind of came up a little bit light, but this is supposed to be 2 inches over here. Okay, that's a 2. It's hard to see even over that. Guess what, guys? Even I still screw up notes when I'm not at school. You still can't read them half the time. Okay, so when I look at this, the important thing to notice is what is the base of this prism. The base is not this rectangle on the bottom. Like I said, the bottom doesn't mean base. Base means which two shapes are opposite of each other that are congruent. Well, in this case, it looks like it's this triangle and this triangle. So this triangle back here is one of the bases, and this triangle up here is one of the bases. What I notice is that's an equilateral triangle. It kind of looks like we got this, this, and they told me that this side is 2 and this side is 2, which also would mean that this side also has to be 2. Well, it puts me in a bit of a predicament, because in order to find the area of this base, we're going to find big B, right? That's the first step. We'd have to do the area of a triangle, and the area of a triangle is base times height divided by 2, or 1/2 base times height, whichever way you like doing the formula. I know what the base is. I know the base along the bottom of this triangle is 2. What I'm missing is the height, because if you jump into this and just say the height is 2, you would be wrong. That's the diagonal. The height is this line that goes straight up and down. So what that tells me is I have to pause for a second and do a little bit of extra math here. We're going to focus on just the half the triangle, this little right triangle right here. We need to know how tall it is for my formula over here. I know this part over here is 2, and I know the bottom, when I come down and I cut this here at the middle, is 1. There's 1 on the left and 1 on the right to make up a total of 2. So I've got this little triangle here, so we're just going to use our a squared plus b squared equals c squared. A squared, Pythagorean theorem, a squared plus b squared equals c squared. In this problem, a and b are the 1 and the h, and c is 2. And so I'll work this out. 1 squared is 1, 2 squared is 4, subtract the 1 from both sides, and I end up with h squared is equal to 3. So when I square root both sides, h is equal to the square root of 3. So this comes up here now and makes this a little bit easier to do. Now that I know the height is the square root of 3, now I can come in and solve this problem. Base is 2, the height is the square root of 3, and we're going to divide by 2. So the only thing I can do here is simplify these 2's. 2 divided by 2 is 1, so I just have square root of 3. 1 square root of 3. So there's big B. P in this one is really easy, right? They gave me all 3 sides. What's the perimeter of this triangle? 2 plus 2 plus 2. So P is equal to 2 plus 2 plus 2, which gives me 6. And the last thing is to determine the height of the prism. Again, height of the prism can be a little bit weird. It doesn't necessarily mean how tall is the prism? It means how far is it from the first triangular base to the second triangle base? Well, since you have one triangle base up here and one triangle base back here, I know that the height between them is 13 inches. So I know that this h is going to be 13. And we just jump into solving it now. Surface area equals 2 times the area of the base, which is square root of 3, plus perimeter times the height, so 6 times 13. Add this all together, we're going to get 2 square roots of 3 plus 13, 26, 39, so it looks like 78. And if I'm not mistaken, I think I just left it here in my notes because I just said, okay, well, I don't know what the square root of 3 is. It didn't say if we were supposed to round. It's kind of my fault because I should have put that. So let's just leave it as 2 radical 3 plus 78 inches squared. Let me see if I really did do that in my note. Actually, you know what? I think in my notes I actually finished solving it. Now that I'm saying that out loud, I sure did not. I sure did not. I left it just like that too. Okay, so there's the nicer version, so you can see it a little bit more clearly. Like I said, this is a 2 over here. It kind of got cut off. All right, I got one more example for us to look at today together. This one is finding the surface area of a cylinder. So surface area of a cylinder, again, comes out the exact same way. I'm going to also leave this one as this exact version. I'm not going to work anything out here. I'm just going to leave it in terms of pi. So the first thing I have to do is I have to find the area of the circle. Well, the formula for area of a circle is pi r squared. So I look up here. It tells me that the distance across this circle is 14. So that means the diameter is equal to 14, which means the radius is equal to 7. So I'm going to plug in over here pi times 7 squared, which will give me 49 pi. Like I said, I'm going to leave it exact. I'm not going to actually work it out there. When I go to do the perimeter, well, how do you find the perimeter of a circle? We can't add up the sides because there is no sides, right? So you use the circumference formula, which is pi times diameter. We know the diameter is 14, so I'm going to have 14 times pi, which is 14 pi. And our last thing to determine is how tall is the cylinder. What's the height of the cylinder? Again, the distance between the top circle and the bottom circle is the height. So they are 10 units apart, so my height will be 10. And I'll plug it all in. 2 times area of the base, so 249 pi, plus the perimeter times the height, so 14 pi, times 10. Simplify what I can here. 2 times 49 is going to give me 98 pi. 14 pi times 10 is going to give me 140 pi. And since they both have a pi attached to those, I can add those together. 140 times, or sorry, plus 98 is going to give me 238 pi. And then we'll put our units in yards squared. And that would be the surface area of this cylinder. So again, let me go back over here so you can see this a little bit nicer written out neatly. There it is, and we would be done. So if you have any questions about surface area of prisms and cylinders, go ahead and let me know. There is your first IXL that you can start working on. It's all about prisms and cylinders only, so you can kind of stay focused on that idea. Have a great day. Good luck.